Today we are working on a test using the Benedict's reagent to test for simple sugars. So if you remember from lecture and lab, simple sugars are monosaccharides and disaccharides. So we're looking for things like glucose and fructose and sucrose. Those are our simple sugars. So the way that we run the Benedict's reagent test is we take clean test tubes, we add our test solution, and then we add 2 milliliters of Benedict's reagent, which is this really pretty blue color. You then put your test tubes into some gently boiling water and leave them there for about 2 to 3 minutes. And then you remove them, and now we're gonna look to see the color of our solution. And that's gonna give us a clue as to the results for our Benedict's test. So here we have our chart on the board. Tells you what solution is found in each test tube. And now we're going to examine each test tube, look at the color, and try to interpret our results. Okay? So for our first test tube, we added water and Benedict's reagents. And you can see after incubation, it's a very pretty blue color. So I'm going to record that as blue on my board. My next test tube had some glucose. So after adding the Benedict's and incubating in the boiling water for 2 to 3 minutes, my solution has turned brown. So I'm going to record that as brown. My third tube contained starch. This is my results. You can see it's still a pretty blue color, so we're going to record that as blue. My fourth tube contains some lemon juice. You can see it's kind of a greenish brownish color, so we'll record that, kind of a green brown. My fifth tube contained orange juice, and that's a pretty kind of orangey brown color. Tube number 6 contained soda. It's Sprite, in case you were wondering. So just regular soda, and this turned a nice brown color for us. Tube number 7 contained diet soda, diet Sprite. So we were consistent with our sodas. So this remains a blue color. Tube 8 is our first unknown. So we did not know the identity of this liquid. What we're trying to do with these biochemical tests is try to figure out what molecules these different liquids contain. So tube number 8 contained my first unknown, unknown A, and as you can see, that is a blue color. Tube number 9 contained my second unknown, unknown B, and as you can see, that turned a brown color. All right, so now that we have these color change results, we need to figure out what they mean and what they're telling us. So as I mentioned, the Benedict's test is going to identify simple sugars that are in the solution. We start out with this blue indicator, and as you can see, in some cases, we did see a color change. So the first tube just contained water, just water and Benedict's reagent. Now we don't expect water to have any kind of sugar molecules, and so this serves as our negative control. It lets us know if you see a color change when you add just plain water, then either your tube is dirty, your water has been contaminated, but something is wrong with your reagents and you need to stop and reevaluate what you're doing. So we expect no color change when we incubate the Benedict's reagent with water, and in fact, we did not see a color change. So we interpret this as negative, and that is our negative control. So I'm happy that that worked out. That's exactly what I expected it to do. Tube number 2 contained a glucose solution. And as you mentioned, or as I mentioned just a minute ago, glucose is a simple sugar. So we expect to get a positive result with this test when we incubate the glucose solution with the Benedict's reagent we expect to see a color change, indicating the presence of a simple sugar. If we did not see a color change, then again, that tells me that there's something wrong. My reagents are messed up, my glucose solution was not what I thought it was, but it's just an indication that something about this experiment is not right, and I need to go back and reevaluate. So, the fact that my glucose solution turned brown, that tells me that this experiment is working the way that it should, and this is read as a positive result. There are simple sugars in the glucose solution, as I expect. So now you know that negative results, the absence of simple sugars, are indicated by a blue color, and positive results, the presence of simple sugars, are indicated by a color change to a brown. With that information, I can now look at my starch tube. Starch remained blue. Now remember, starch is a saccharide. It is a carbohydrate. But starch is what we call a polysaccharide, meaning instead of just consisting of a monosaccharide or two monosaccharides together, a disaccharide, starch is a polysaccharide. And so we have hundreds or even thousands of glucose monomers hooked together to form that starch molecule. Because Benedict's only tests for those simple sugars, those individual sugars, it cannot react with the starch to indicate that there are simple sugars present. So starch is a negative for simple sugars. My next tube was lemon juice. And we normally think of lemon juice as being very tart, very acidic, and it is, but there are some sugars in lemon juice. And so this was also a positive because of the presence of those sugars. So we're going to read this as a positive. Orange juice, you know that orange juice tastes sweet when you drink it, and the reason why is because of the presence of those simple sugars. So we did see a color change from our orange juice. Instead of being blue, we did see this color change to a kind of orangey brown, and so that is read as positive as well. Soda. Again, soda tastes sweet. The sweetness comes from the presence of simple sugars like glucose, like fructose, like sucrose. So it's no surprise that our soda showed a positive result. Our soda turned brown after incubation. Diet soda. This one might surprise you. So diet soda still has a sweet flavor to it, but it is a low-calorie soda. The reason why is because instead of using a sugar like glucose or fructose or sucrose to sweeten the drink, they use an artificial sweetener like aspartame, which has a very different chemical structure than glucose. Therefore, that sweetness comes from the artificial molecule, not a simple sugar, and our diet soda remained blue, indicating that it is negative for the presence of simple sugars. Looking at our first unknown molecule, again, we don't know what's in these solutions, but looking at our first unknown solution, we see that there was not a color change. So whatever is in unknown A, we know that there are not simple sugars in this solution. The blue tells me that this is negative. And finally, unknown B, my second mystery solution. Again, I don't know what's in there, but I do see a positive result for the Benedict's test, which tells me that whatever else is in this material, there are some simple sugars to be found. So we're going to record this as a positive. All right, so that is your Benedict's test. Again, we're looking for the presence of simple sugars, things like glucose and fructose and sucrose. Normally, the reagent is blue, as you can see. Once we incubate Benedict's in the presence of simple sugars and we heat it up for a few minutes, we see a color change if the solution is positive for simple sugars. So we go to this brown color. And so as you can see, by interpreting the color change of these different solutions, we can identify whether or not they contained simple sugars. If you have any questions, please contact your instructor.